Hey friends, welcome to another video of training. So today's video is going to be a bit different than other videos. If you see or look at your screen, on your right, you're going to see what my phone is seeing. And on your left, you're going to be seeing what my laptop is reflecting on the monitor, on the screen. And that's going to be important because today we're going to be going over building automation. What is building automation? And the end goal is to get this controller, building automation controller, to call for cooling for this heat pump package unit. That's it for today. Because when you look at that, and yeah, I'm being a little bit messy right now, but in all honesty, though, uh, a lot of the times there's a bunch of wires, and you're like, this is so overwhelming. So today I'm just gonna keep it simple because that's all I want you guys to get from this. It's just how this controller works, and you'll be able to see the programming and the graphics behind it too. So um, let's start off with this right here. All right, this thermostat, a lot of the times, if you're working with a heat pump, you actually have to tell it that it's a heat pump by going to the advanced settings. But can we agree that all the thermostat is doing is that it's receiving 24 volts here, 24 volts, and if I have a call for cooling, now have in mind it's a heat pump, so it needs to send 24 volts to my Y and my O, right? My Y and my O. So what it does internally, the R is like, here you go, and it gives 24 volts to Y and to O, and that's cooling. So that's all the thermostat is doing, and we can confirm it if we go here, and let me get some alligator clips. So today it's going to be more of a raw video. I'm just going to be uh, just grabbing the things I need, and it's not going to be as formatted, if that's the word. So I'm just gonna go with the flow here. So I removed the thermostat because I'm not using the thermostat. So can we agree that when a thermostat, all it's doing is, you're grabbing your power right here, right? Your red, your power, right? Make sure that doesn't come off, and then your reversing valve, which is your orange wire, right there, and then my yellow one, which is for my compressor. So you see that came off right there, but that's okay. We'll put it back. So the thermostat, all it's doing is you want that red wire to touch the yellow one and the orange one. That's all we're doing. That's all the thermostat is doing when it has a call for cooling for a heat pump. And we can confirm that, right? I'm gonna go ahead and get my power. Go ahead and send 24 volts to my reversing valve. And then this is what's gonna engage and turn on the compressor by sending jumping the R to the yellow wire. So let's go ahead and do that. Okay, so you can see it's on, and now we're cooling, right? This is a return. That's the supply, and I can feel it coming out cold. That's what a thermostat does. That's it. Okay, you're gonna see how simple this building automation controller is. I'm gonna go ahead and remove the wire nut. So we're not gonna use any jumpers. I'm just gonna put everything back. Okay, or and I'm going to show you what I'm doing with the wires as well. I think that's important as well. So now let's go ahead and put that back. Okay, so everything's wire nutted. So I actually had to get 24 volts from the package unit. So the package unit is sending power to this. So this controller takes 24 volts, 24 volts AC, right? And then this backnet router also takes 24 volts. So these two are coming all the way right here, right? Right there. And so I'm basically just sending 24 volts from the unit. And you can actually follow it, right? If you were to follow this wire here, this wire, the red one is going to my R, and then my white one's going to my common. Okay? So it's sending 24 volts. Okay. You know how we said the thermostat is just a switch. Okay, it's just a switch. Okay, so let's take this thermostat to show you an example. So Okay, so this part here, these are binary outputs. So all we're doing here, imagine the thermostat, the backplate, right here. Because like we said, when I have a call for cooling, 24 volts gets sent to Y, and my wire coming from the O to get cooling. Same thing here, but it's a little bit different. Um, we actually need to send power first to these right here, to my 2 and to my 5. Because if you see the little, the way the schematic is, the little symbol, it actually has constant power at 2. And if you want to send power to number 3, you have to have an on signal or a yes signal to binary output 1, which I'll show you on the programming on the back end. So I have to send power to 2 and to 5. And if you follow this wire here, this red one, if you follow it, it actually is getting power right there. So it is getting, we are giving it 24 volts. So power is right here. Okay. So the wires, like for example, this Y and the O wire, I know I don't have anything connected here, but let's pretend it's just an orange wire coming out of the O. Those are gonna go on 3 and on 6. I'm gonna use binary output 1 for cooling, binary output 2 for the reversing valve. And if you follow this green wire that's on 3, if you follow it, it goes to this wire here, which I taped, and it's Y. If you go to binary output 2, on number 6, I have this yellow wire coming out, going to this right here, the second spacer slot, and then I have this red wire that says "Oh." So they, if you want to think about it this way, the for these right here, it's basically my Y coming out, my Y, and my reversing valve. That's it. So this white one, this yellow one, right? This is cooling. Or in this case, it's a heat pump, so it's going to the contactor. This one needs to be wire netted to my yellow wire in the package unit. The O, because I'm using it for my reversing valve, needs to go connected to my orange wire in the package unit, which is for my reversing valve. So this is for my compressor, the contactor, and this is for my reversing valve. Y and O. So let's follow the wires. Okay, I'm gonna follow it. I'm following it. I'm following. Yes, it's a bit messy. It's Friday. It's yeah, that's all I gotta say. It's Friday. So Y goes to my yellow wire, right? And then O goes to my reversing valve. So that's done. So we got that taken care of. So essentially, if I do this, if I get a little alligator clip from this power and give it to the green one and my yellow one, guess what? We're sending 24 volts to my contactor and my reversing valve. That's cooling. I can jumper it, but whether you're a thermostat or building automation, working with building automation controllers, you're not you're not gonna be like, Mrs. Applebottom, I got you. If you need me to call for cooling, let me know, and you're just gonna be on standby next to the unit. I mean, that would be ridiculous, right? We have the thermostats to do that, or in this case, the building automation controller. Okay, so that's done. The binary outputs, your switches, that's down here. So we also need to be, because we're not using a thermostat, we need to be able to read temperature. So right here, I have thermistors, 10K type 2 thermistors. It's just a special tubing. They're temperature sensitive resistors, but it's just a special tubing right here, and they have 2 wires coming out. So I got the my return and my supply. The way I can remember it, it's not always the case, but the word return, which is what sucks the air in, is the word return starts with the letter R. The word right starts with the letter R. So my return is my right side, and my left is my supply. So both, I already have wires connected coming out. So this one here, let's go ahead and follow. Let's do the return first. And like I said, it's a bit messy. It could have been a little bit cleaner, but obviously on an install job, you wouldn't do this. So let's go ahead and get the 2 wires here. All right, and typically you bring the wires right here, and then you cover this with the panduit so you can't see it. So what I'm gonna do is, so look at this right here, right there. So my black is basically my ground, and then these white ones are inputs. So if you look at here, let me see if I can kind of adjust my phone here. You have a lot of stuff here. Remember, we're just using these two up here, so we don't have to worry about any of these in the bottom. Thermistors, you're basically connecting one to an input and the other one to ground. So this is what I'm gonna do. First, I'm gonna identify my black one, my ground, and look, if you follow it, it goes right there. It goes to number 8, and you line it up here. Number 8 is ground. So let's do that first. Let's go ahead and connect it to ground and make sure that it actually goes to the right one. So I'm gonna just go ahead and you actually have to strip the wire a bit and then just screw it in. Okay. All right. So you do a little pull test. You're good. This red one here has to go to an input, and you're gonna see why that's important later. It needs to go to an input. So let's use this white one here. This one. So we were to follow this white one here. Let's see. It goes right there, and I have to follow it. Yep. So it goes to, let me see, right there. It goes to number 9. If you follow number 9, it says input 5. Okay, so we need to remember that the return air sensor, the thermistor, I'm connecting it on input number 5, right? Number 9 is 5. Yep. So I gotta put that. So I gotta make sure I put it wherever this wire is coming from input 5. I have to make sure I put it on the right one to the right side. So I know that it's gonna be this one here. So let me go ahead and do that. And we connect it. Okay, so that's done. I'm done with my return air temperature sensor, my thermistor. That's done. Let's do the supply. So, okay, so this is the supply. Same concept. Same concept. So let's bring the wire here. And you could actually do this. The ground, which I'm going to use, that's the white one. I'm going to go ahead and put it on the same one while I put the ground for the return. That's okay. They can share the ground, the common. So I'm going to go ahead and put that in there. And they're both going to be in the same hole. Same hole. Okay. All right. I'm going to do a little pull test. Good. And then I'm going to use the one that I'm not using. I'm already using input 5, but we're going to use the top one. And if you were to follow it, it goes to number, and I can see it right here, number 10, and that's input 6. Input 6. Okay. So let's go ahead and put it on the top one here. Okay. And you're going to see why this is important. Okay. Right now, we need to be able to read temperature, right? So, all right. So all the wiring is basically done. That's it. We're done. We're done with the wiring. And so now we're gonna go to the the programming side here. So let me see. I might have technical difficulties. Yeah, okay, I don't. I'm actually okay. Good. I think we're good. Um, yeah, something is not communicating, and that could be as simple as this comm wire touching each other. And hopefully that was the case. Okay, now you're seeing cannot communicate to the controller. So that is not good. So let's see what's going on. So a lot of the times, and I didn't actually plan for this, something always happens, but you have the TX and the RX transmitting. TX is transmitting, RX is receiving. And so you see if they're both flashing pretty like heartbeats, that's a good sign. My network, it's pretty good. Let's see if I might have to pause the video and then come back for you guys to see what's going on. Or maybe I might just have to reset everything. Okay, we're getting check marks. Let's see. Did it work? All right. Okay. So let's do this first, okay? Now you can go ahead and look at the bottom, at your bottom left. So let's go ahead and do this. Let's go ahead and put 0 here. That'll make sense right now. Okay. All right. So when you look at the programming here, this is a programming. I am doing the a supply air temperature. So this is an analog input, and I'm coming out, so we're able to see the actual temperature, and then this is the little label. Don't worry too much about it. All I'm doing is that I have a way in the programming side to create the block for that thermistor. The return air temperature is the same, but look at the control sequence. I made it as simple as I could. If my return air temperature, and then this is a block that maybe we're familiar with from math class, but if my return air temperature is greater than my set point, it's going to send an on signal. And I did put a minimum on and off timer. So that means that if it receives an on signal, it's going to wait 30 seconds because I put 30 seconds right here. It's going to wait 30 seconds before sending 24 volts to my Y and my OB. And when it turns off, when it receives an off signal, it's going to wait 30 seconds before it turns off. And what I mean by that is when it receives an on signal, my power from right here, binary output 1 from 2, and binary output 2, number 5, they're going to go like this. Boom. So then 2 is going to give 3 24 volts. 5 is going to give 6 24 volts. And whatever wires I have coming out, that's going to receive 24 volts. And then these wires, I have a green and yellow that essentially end up being my Y and my OB because we already followed the 2 wires coming out. But we have to map out the points. But this is just basically the simple program. I just wanted to show you guys this first. And then this is the graphics. So when we have a call for cooling, this is going to turn blue. The fan's going to turn on. And then my supply air temperature is 0 right now because I haven't mapped out the points. Now, one thing I did forget to do. So I have to just make sure that I am not mapping out the points to anything else, like stuff like that. You see, I got to just zero out other programs. I'm going to just go ahead and do that real quick. Okay, we're good. We're good. Okay, so now let's go to T-stat. So if you remember the return air temperature, I put it on input number 5. Input number 5. Look at what's going to happen when I do this. I'm going to go click on here, on this one here. And let's see if I can zoom in. All right, that's awesome. So right here. So yes, I have to actually, I labeled it as RAD, return air temperature, Fahrenheit. It's a universal input. And then I went here, and this is important too. It's a 10K type 2 thermistor, but I actually have to put it on, I have to tell it, hey, you put it on input 5, but I don't know that. You could actually tell me where to look at. That's basically what this is doing right here. Don't worry about this right here, just right here. So look at that. Look at that change to a temperature. All right, you see 72.4. So now I can see 72.4 degrees here. You see, now I can, because I have this temperature, I can work with this number and now call for cooling. And I still got to do the supply temperature, right? So let's go ahead and, I think it was number 6. We might have to go back and confirm. All right, 71.5. Cool. So we got temperatures, and we're not done yet. We still have to map out my binary outputs. So we did say that my cooling my contactor is on this green one. So that's binary output 1. So that's for contactor, and then my reversing valve is on binary output 2, right? Because if you follow number 6, it goes to that yellow wire, which goes to this red wire, which goes all the way to my orange wire, which is a reversing valve in the unit. So my Y is 1. Let's go ahead and do that. My Y is 1, and then my OB is 2. I have to tell the program, look at you. You're gonna send 24 volts on these binary outputs, because if I put 0, it's not gonna know. Even if the program is calling for cooling, it doesn't know where. You have to map it out. You have to tell it, hey, look at these points right here. So this is again the logic, a simple logic, guys. Like I said, if we go over the set point, so this is a set point, which is the same thing that you can kind of, change the set point here. It's just a logic. They call it a logical block. I could be wrong in there. Software point. They call it a software point because you can't see this. You can see the supply air temperature, right? You can see it. It's right there. I could see it. I can see the return air temperature, but this is a software point. I can't see it. I can only manipulate it here. So I'm gonna put a set point of 75. So right now you see the program is working because 72 and this block, right? If let's say 2 is greater than 1, yes, or on signal. 72 greater than 75, it's off. It's not true. So before I do that though, I just want to make sure everything's looking good. I don't have any problems. So I want you to see this right here, okay? And I'm actually going to be able to step away, and you're going to be able to see it here from the graphics, right? And that's why graphics are important, because just because you call for cooling, let's say you're low on charge, this supply air temperature is not going to drop. So it's important to just be mindful of that. Just because you send an on signal, you tell something to open, it doesn't mean that it's doing it. So you always have to look at a supply air temperature or a feedback, some way to make sure that it's actually doing its job. Yes, compressors can definitely be low on charge, and you call for cooling and it's never cooling. Same temperature, return and supply. It's not dropping in temperature. So let's go ahead and do that. And I can confirm it right here once we send an on signal. So I have to go here to the logic. And so I can either fake it, and I forgot to bring my wife's blow dryer, because I can actually warm this up a lot so that I can be over 75, or I can just drop to 75 to 70 for a colder ambient room. So I'm just going to do that. I'm just going to drop it to 70. 70, okay, accept. And look at 72 is greater than 70. It turned it on right away. And I might have forgotten to edit this little block here, but that's okay. I just want to show you guys. Look at this. This is my return air temperature. Look at this drop right now. Look at this drop in temperature. You see 70, and we're going to let it do its thing. I'm going to confirm. And I know we're sending 24 volts because the system turned on, but I'm going to go ahead and just show you what I mean. So when I troubleshoot, I like to use my comment as my reference. And what do I mean by that? Well, look at this. So I'm gonna go ahead and have that. So where's my comment? I did add comments here. So this comment is the same as this comment here on my ground. Same thing. But I'm gonna put it here. So between common and hot is always 24 volts, right? And we can confirm that by going to number 2, which has constant power. My binary output 1 is my contact, my compressor is coming out of this green wire, number 3, and then the reversing valve is the yellow one. I can go ahead and confirm. And you see what happened right now? Now I'm not calling for it. And you know why I'm not calling for it, right? And this is good for you guys to see. Look, I'm going to confirm. Actually, this was not planned at all, too. I'm going to go to common. I'm going to go to 3. And I should have 24 volts, but I don't because it's not calling for it. And I know that because I heard the system turn off. So when I go here, let's see what's going on the logic side. You see, I'm it's now okay. So that's funny what it's doing here. It dropped in temperature because my supply is so close to the return. It's like fighting each other. I don't have ductwork coming out, so I should have put something in the middle. But you see, once again, my return air temperature is above 70 degrees. So now I have an on signal, and now okay. So the actual system package unit actually has a 5-minute delay. And I don't know if you knew this, but you can actually bypass that 5-minute delay. In the back, there is a speed up, and I don't know if you can see that, but a speed up. You just short the little pins to each other. Okay, that turned on. Let's see if I can show you before it satisfies again. But I'm gonna go to common, and then I'm gonna go to 3. You see, 24 volts. So my binary output 1, it's true. It did close between 2 and 3. See if I can go this way a bit. It did close between 2 and 3 because I'm reading 24 volts from common or my ground to 3. I'm gonna check my reversing valve. You see, yep, it's 24 volts. So that means that I did send an on signal to binary output 1 and binary output 2. And and then I know that it's cooling because when you look at the graphics, you see I have a supply air temperature of 54, 53 degrees. You don't know how many times you go to a job and or even a building engineer can look at a system and it's calling for it, but then the supply air temperature is not dropping. But in this case, we know we're cooling. We have a good delta T. Typically you want an 18 to 21, but this is going to mess it up right here because we're so close. I think this supply slowly is coming here to my return. You see, and just like that, it turned off because we're below, right? 69.8 is not greater than 70. So then I am not going to have an on signal. So it's going to be doing that on and off, on and off. Of course, this is just a basic program. There's other parameters, other things you do, so you don't have this issue. I kind of messed up, maybe I think on the minimum on and off block, so I gotta fix that. But you guys get the point. All we did is use a thermostat. Uh, the idea of a thermostat right here in this section right here, right? Because just like in the thermostat, I can jumper stuff. Right here, I could technically jumper the power with my contactor, my power with my reversing valve, which is on 3 and on 6. But we can use thermistors to read temperature, create a program that we download to the program, and then send an on signal to my binary output 1 and binary output 2. Typically, in a building automation controller, sometimes you have your inputs on one side, your outputs on this side. This specific one, though, you have your inputs and binary inputs, analog inputs and binary inputs here. You have your analog outputs here, and then you have your binary outputs. So analog outputs, binary outputs. And this is essentially just switches. And then right here, you would use this for economizer, cooling and heating, like actuators that receive 2 to 10 volts DC signal right here. And then the wiring, yeah, it's a mess. But as long as you map it out correctly, you do the install correctly, that's really it when it comes to building automation. If you guys have any other ideas as to what you guys want to see, I do want to start putting more of this, maybe getting a little bit more deeper into the networking when it comes to the backnet router or the master slave token passing with the MSTP with your COM cable. Just you want to just see maybe how this unit, whatever happens here based on a program, it will turn on this unit. Maybe you want to see something else. Maybe you have it. You've had a question about it. No one's been able to explain it. You guys already know how I am. I do my best to try to explain it in a simple way. And let me know if my videos are a little bit too advanced or complicated. I'll keep it more simple. At the end of the day, I just want to give back to you guys. I really want you guys to be successful. I know how it is, especially in the building automation field, how it is when you're out on a job and someone tells you, "Hey, just figure it out," and then you can only call so many people and go to Google so much or YouTube, and it's hard sometimes. But if you guys build a good foundation, from there you can take it. You can take it from there. So if there's any other ideas or suggestions, let me know. I'm here for you guys. Spread the word to others. My channel is just providing free building automation and HVAC knowledge. I really hope you guys are doing all well out there. It's gonna start getting. Well, it's been getting warm here in Southern California, but you know how the weather is; it kind of fluctuates a lot. But just stay safe out there, guys. And I hope this video helped you out. I will catch you on the next one.